Okay, for some of you that were gone today, I thought I would just post the notes for 6.3. What I also did was I went over some things from 6.1, so that's what I'm going to do first. X to the third times x to the fourth. Bases are the same. You might be saying this in your head, just practicing to make sure if you remember 6.1 is x to the seventh. You add your exponents. If it's a power raised to a power, if it's a little guy raised to a little guy, it's multiply. Another one is 3x, all of this raised to the negative 2 power. Negative exponents, you flip it, so it'd be 1 over 3x to the positive 2. And then you still have to simplify that to 1 over. Some people think 3 squared is 6, but 3 squared is 9x to the second. That's kind of a quick little review on 6.1. 6.2, we learned how to do long division and synthetic division. For example, 3x to the third minus 2x to the second plus x plus 4 divided by x plus 1. You put the x plus 1 on the outside, and you put the 3x to the third minus 2x to the second plus x plus 4 on the inside. You compare the x with the 3x to the third, and it's missing 3x to the second. You multiply 3x to the second times x, and you get 3x to the third plus 3x to the second. Draw your line. Don't forget to do what? Right? Yes. Flip your signs. Switch your signs. Divide to the first one, but a negative 2x squared minus 3x squared is a negative 5x squared, and then bring down your x. Compare your x with a negative 5x squared, and it's going to be a negative 5x squared, minus 5x. Draw your line, switch your signs. Again, that cancels out the first two terms, or the first term. X plus 5x makes 6x. Don't forget to bring down your 4 again. Compare x with 6x, and you're going to have a plus 6. 6 times x is 6x. 6 times 1 is plus 6. Draw your line, switch your sign. Remainder of a negative 2. I'm going to do the same thing, except synthetic division. So you make a half a box, or you can make a full box, whatever. You set the denominator equal to 0 and solve for x, and you would get a negative 1 in that box. Then after the negative 1, you put those coefficients after, and make sure you're not missing a power, so it goes 3, negative 2, 1, and 4. And if you remember, you leave a space, and then you make another box at the end, which stands for the remainder. Exact same problem, except synthetic division instead of long division. Bring down your 3. 3 times a negative 1 is a negative 3. Add it up. It makes a negative 5. Negative 5 times a negative 1 is a positive 5. Add it up, makes 6. 6 times a negative 1 is a negative 6, with the remainder of a negative 2. You get the same answer. Remember how you put this back into polynomial? Just a quick little reminder. It's always 1 less than what you started with, so your final answer needs to be to the second power. So it's 3x to the second minus 5x plus 6, remainder of a negative 2. So that's what we've learned so far in 6.1 and 6.2. Now I'm going to teach you what we learned in 6.3 today. So on this page, it just explains different types of polynomials. There isn't much on this page that you have to take notes on. Maybe you didn't know that x to the first, when you graphed it, it made a line. It's called a linear equation. X to the second, we learned how to graph those. Those were quadratics. That was chapter 5. And now we're going to get into bigger ones called cubic, and even bigger one than that. We're going to get into x to the fourth. We're going to get into x to the fifth, x to the sixth, x to the seventh. We're going to get into some big ones later on in this chapter. So, I think I'm going to wait and explain this last couple of columns on the next page. So that's it for this first page. Okay, this is where I'm going to explain those other two columns to you. Like I said, we're going to get into bigger polynomials. Here's the first problem right here. 8x to the fifth minus 4x to the third plus 2x to the second minus x minus 3. Later on in this chapter, we're going to learn how to graph it, but we have to do baby steps up until we learn how to graph it. So the first thing we have to learn is what a degree is and what is the leading coefficient for all of these problems that are on this template. So the degree is the highest power. So if you look at all of these, here's one term, here's the second term, third term, fourth term, and fifth term. And the highest degree is 5. And the leading coefficient means the number in front of the highest degree. That leading coefficient would be 8. And that's all you're doing for the first part of the assignment on the worksheet that you have to come get. What I do is just circle the highest degree is 3, and the number that's in front of the 3 is a 7. So that's all you're doing on the worksheet. The next two, I circle the highest degree one, which is 3, and the leading coefficient is 6. And the last one, I'm going to circle the highest degree is 3, and the leading coefficient is 5. So when you come pick up your worksheet, that's the first thing you have to do on the worksheet. Okay, the third part of the worksheet, I skipped down to the third part of the worksheet. This has been seen on the ACT. They give you a polynomial. Here's the polynomial. P of x equals x to the third plus 3x to the second plus 4x minus 7. And they want you to find P of a negative 2 on the ACTs. What you did was you substituted in place of the x, you substituted a negative 2 in for the x. So that means in place of all of the x's over on this side of the problem, you're going to substitute a negative 2 in. A negative 2 times a negative 2 times a negative 2 3 times makes a negative 8, plus a negative 2 times a negative 2 2 times makes 4, and 4 times 3 is 12, minus 8 minus 7. So your final answer is a negative 8 plus 12 makes 4, and then 4 minus 8 is a negative 4, that makes a negative 11. So that's what a P of a negative 2 would look like on the ACT. And then I did another one. I did P of 4, which means replacing all the x's with a 4. And when you replace all the x's with a 4, I think you're going to get 121. We didn't even do the bottom problems because they didn't want any more, because they understood how to substitute the number in for the variable. Okay, the last part already is this big chart that I have to explain. So every graph in math has called the end behavior, how it ends. Whenever you read a graph from left to right. So these are the only types of graphs that there are. The end behaviors. The end behavior means it can start up, and then it can do something in the middle, but then it ends up. That's the first end behavior. The second end behavior, it can start down, and at the end, it can end down. That's the second end behavior. The third end behavior, you can always read a graph from left to right, start down, but then end up. And the third end behavior, it can start up and end down. We're going to learn how to graph in the next section, and the reason why you have to know this is all of this over here now. It depends on the degree and the leading coefficient, just like we did on the first part. If the highest degree is an even number, as you can see these are both even, then it's going to start up, or start down and end down. That's if the highest degree is an even number. And if the leading coefficient is positive, they both end up, and if it's negative, they both end down. Same thing with this. If the highest degree is odd, but if it's positive or if it's negative, that's what this means, then these are the pictures that associate with that. Okay, I added an extra page, and here's the extra page. End behaviors can either end both up, start down and end down, start down and end up, or start up and end down. These are called the end behaviors. And it all depends on if it's even and positive, even and negative, odd and positive, or odd and negative. You will get this chart on the test. You do not have to memorize these 4 charts. I even put so you'll have the 4 charts. I don't know, I know you're going to get the 4 up there. I don't know if you're going to get this, but all I remember is odd, they go in different directions. Even, they go in the same direction. Positive, they both face up. Negative, they both face down. So, but anyway, you're going to be given a polynomial, and I'm just going to do 2 on this page so that you get the idea of how to do the worksheet. And I'm just going to give you 3x to the third minus 2x to the second plus 3x plus 4. And then I'm going to give you a negative 8x to the fourth plus 3x to the third minus 2x to the second plus 3x minus 4. And now all we're going to do is to get ready for the next section. I'm going to do what I did at the beginning part. I'm going to find the LC, the HD, just like we did in the first part. And I'm going to look at this huge polynomial, and I'm going to circle the highest degree, and this one is 3. And the leading coefficient is also 3. And I'm going to do the same thing down here. The leading coefficient is a negative 8, and the highest degree is 4. Now comes the new part, the ED, or the ED. That's the last part. So I'm going to do the last part. I'm going to look up at the chart. And when you look up at the last part, the highest degree is 3, so it's odd. And this is a positive number out in front. So the highest degree is 3, and it's odd. And the leading coefficient is 3, which is positive. So I look at a positive and odd, and I look up above, and positive and odd starts down and ends up. And now we look at the last one. I think you guys are catching on to this, I think. The highest degree is 4, and 4 is an even number. And the leading coefficient, I really don't care what the number is. I really care that the number is a negative number. The negative, it's a negative even number, and since it's a negative even number, I look up here. It's negative and even, starts down and ends down. So this is called the end behavior model. Okay, now the last page, and we're done with notes. Without a graphing calculator, you can match the equation with the graph. So without a graphing calculator, I can look at the first one right here, and I can see that this is the highest degree, and this is the leading coefficient. The highest degree is even, and the number out here is a negative number. And if it's an even and negative number, then which graph starts down and ends down? It can only be B, because that's the only graph that starts down and ends down. And then we do the next one. This is an odd highest power, and the number out here is a positive. If it's a positive and odd, it needs to start down and end up. So this is the graph for 2x to the third plus 5. And we can keep going. This is even. and this is positive. Even and positive, it starts up, it ends up, would be right there, and then process of elimination would be the A. These are quick notes. They're only 15 minutes long, but I think you get the idea of what you missed. So watch these videos, come get a worksheet.